Good morning, students. Myself, Vijay Shankar from EC Department, Chevrolet Engineering College. Today, I am going to discuss about the transform properties. In the last class, we completed up to the initial value theorem. Now, coming to the final value theorem. The final value theorem also, seeing here, the final value theorem stating that x of n is a z transformation of x of z. When x of n is a causal signal means it's the right sided down. That's one-sided signal. One-sided means unilateral. But it's stating that limit n tends to infinite. Now, the previous day n is equal to 0 as the initial, and finally it is a n tends to infinite x of n. X of infinite, the limit z tends to 1. Z tends to 1, z minus 1 x of z. Z tends, not the z tends to 1, z minus 1 x of z. What it matters, students? So to prove this final value theorem, we have to know the shifting property. The shifting property we did the two-sided z transformation and the one-sided z transformation also. Okay, my dear student, one-sided z transformation also. That one-sided z transformation is a one-sided only, and x of n plus m, x of n plus m, this is a transformation of x of n plus m plus m is, it is a towards the right side. This is a transformation of x of n minus m is towards, it is a left hand side. This is a left hand side, and this one is a right hand side. The positive values of m and negative values of m is becomes of minus is a plus. What is the z transformation for this? As a unilateral, not the unilateral, bilateral. Simple, it is a z power, again the positive values of negative values of m. It is a positive power of x, z. And z transformation here for positive values of m, the negative powers of z, x of z. So bilateral, nothing but the two-sided function. Got it, my dear students? One-sided means there is a one signal is added, one term is added for the z power m x of z. Okay, when term is added, z power m x of z and z power minus m x of z. That is here, I am taking the x of n plus 1. Yesterday I told that z of the z transformation of x of n plus 1 is equal to, the z transformation is, already z transformation is there, is equal to only. Here also the z transformation, it is equal to only. And z power, what is the m here? M is a 1. 1 into x of z minus z into x of 0. Z into x of 0. Still it is increases. It is becomes of z square. And here the z square x of z, and it goes on increasing this one, and this value is decreasing. The power is decreases. So what I am saying here, z square x of z minus z square x of 0 minus, it is increases this one, this is decreases. Z power 1 x of 1 and so on like this. So use this function as n is equal to 1, m is equal to 1 only. Here x of n plus 1 is equal to z of x of z minus z into x of 0, because only the one function is there. What is, students? Now on both sides, see here, on both sides taking here the minus z trans z of x of z, the transformation of x of n, and z of x of z is already there, and I minus is there the x of z. So we'll explain clearly the z transformation of x of n plus 1, the one-sided signal with the sample, one sample is shifted. The formula is z of x of z and minus z of x of 0. So what I am doing here now is the transformation of x of n plus 1 minus x of z. I am subtracting in the left hand side x of z and z of x of z minus x of z minus z into x of 0. Why it is in the statement saying that x of z is multiplied with the z minus 1. So already the z is there. You can subtract the minus x of z. Taking the x of z is a common, you get the z minus 1. To prove the final value theorem, I am subtracting on both sides with x of z. So in the left hand side, I am rewriting that as z transformation of x of n plus 1. What is the x of z actually? You can write as z transformation of x of n is equal to x of z only. Okay. Otherwise, x of n is a pair of x of z. I'm writing this x of z as z transformation of x of n is equal to, take the common here, this x of z. X of z, you can take the common. What is the multiplication factor here? Z minus 1 minus z x of 0. Got it, my students? So now here the z transformation, here also the z transformation is there. Apply the z transformation, sum of n is equal to minus infinite to infinite. What is the signal here? X of n plus 1, z power minus 1. And for these also the z transformation is there. Sum of n is equal to minus infinite to infinite. X of n, z power minus n. And write this is equal to z minus 1 x of z minus z into x of 0. Okay. See, in these two functions, sum is common and the z power minus 1 is also common. Take that is a single term. Sum of n is equal to minus infinite to infinite x of n plus 1 minus x of n as one signal z power minus n. What it matters to us is equal to z minus 1 x of z minus z into x of 0. Okay. Now expand this function. Since it is not the minus infinite, because we are using it is a unilateral Laplace transformation, start from the 0. Here's one-sided only. Causal signal. Causal signal means right hand side. And this also from 0 on. So expand with the 0 here. So x of 0 plus 1 is a 1 minus x of n is a 0. Whole multiply with z power minus n is a z power minus 0 as the first term, plus second term x of n is a 1, 1 plus 1 is a 2, x of 2 minus x of 1 whole multiply with the z power minus 1 plus up to so on is equal to z minus 1 x of z and minus z into x of 0. What is minus 4? Minus z into x of 0. z power 0. What is the value of z power 0 here? 1 only. X of 1 as a plus value, and here it will get the minus. X of n and the x of plus 1. So expand when it's a limit z tends to 1, as here in the right hand side, the limit z tends to 1 in this equation. Limit z tends to 1. Here also you can take the limit z tends to 1 in the left hand side. Z is a 1 and the z is 1 here. So anything 1 power, anything with a value is a 1 only. Anything power 1 is a 1 value only. And what is in the parenthesis here? 1 minus 0, 2 minus 1, and the next value is 3 minus 2. Because of 2 plus 1 is a 3, and 3 minus 2. Okay. And apply the limit on both sides. So here is equal to. Now I'm taking the limit z tends to 1. And here also the limit z tends to 1, the second function. Totally these are two functions. And for this function also you can apply the limit z tends to 1 for expansion function. The product z inverse, z power minus 2 and so on, all the values is a z. And here the x1 of x of 1 and the minus x of 1 cancel. Here we get the x of 2, and there the next term will get the x of 3 minus x of 2 z power minus 2, the value is there. So x of 2 is also get cancelled. So on all the terms in the left hand side except the x of 0, except the x of 0 here, remaining all the terms is cancelled. Got it, my dear students? X of 0 the value, and in the right hand side also x of 0, that to minus is equal to, in the left right hand side, limit z tends to 1, z minus 1 x of z. I'm not substituting the z1 value here. For the second term, summation term is there, we can substitute the z. Z tends to 1 means it becomes of minus x of 0. Minus x of 0. Got it, my dear? And this minus x of 0 and minus x of 0 is get cancelled. Okay, and so on. What is the last term here? Also x of infinite. All the terms is get cancelled, and there is a infinite term is there. Infinite term. When I'm substituting the n is equal to infinite plus 1 minus infinite term. Infinite plus 1 minus infinite means one, before that value is also get cancelled. X of infinite. So here the x of infinite will get, and this we can write as a limit n tends to infinite x of n is equal to x of infinite, that is equal to limit z tends to 1 z minus 1 x of z. So only one thing you have to remember, you can use one-sided z transformation shifting property with a sample of 1. Then on both sides we can subtract with x of z and write this function as in terms of this transformation definition and simplify. Got it, my dear friend? You see here x z into x of x z into x of z minus z into x of 0 you can check here, and see the minus z x of n, and already these are multiplied with the x of z with the z minus 1, and that is equal to the sum of n is equal to minus infinite x of n z power minus n is a z transformation, and these also the sum of n is equal to minus infinite x of n z power minus n, this term, the definition of the z transformation. And in the right hand side, z minus 1 x of z minus z into x of 0. Expand this function as 0 is equal, substitute there, x of 1 minus x of 0 z power 0, x of 2 minus x of 1 z power minus 1, x of 3 minus x of 2 z power minus 2, and so on. And you can write this here also. So what is the last term after substituting the infinite? X of infinite plus 1 minus x of infinite. Okay. And z power minus n. Z power minus 1 also. Minus infinite. It becomes of the 0 actually. So in this, all the z terms is a 1. Limit, apply the limit z tends to 1 on both sides. Z tends to 1 on both sides. If it is a z power minus infinite means definitely it becomes of the 0. But I am substituting the z is equal to 1 here. 1, 1, 1, 1, all the terms. Got it, my students? So see, the limit z tends to infinite. Z minus 1 x of z minus z tends to 0. Z of x of 0. This is the right hand side function. X of 1 minus x of 0. Z power 0 is a 1 power 0. X of 2 minus x of 1, z power 1, 1 power 1 is a 1, and so on. Okay, so x of 1 and minus x of 1, and x of 2 for the second term, there is x of minus x of 2 will get. Like that, all the terms is get cancelled, but the last term is x of infinite is will get. So x of 0 and x of 0 get cancelled. X of infinite is equal to limit z tends to 1. Z minus 1, x1, x of z. Okay, the final value theorem. And these all the conclusion of all the properties we have. The first one is a linearity property. So linearity property. Linearity property saying that a1 x1 of n, a2 is a a2 instead of a2 they are taking the b here. A x1 of n, the b x2 of n, a x1 of z and b x2 of z. And second property is the shifting property. Shifting property. In that shifting, m is the positive values, negative powers of z is multiplied for the unshifted z transformation. And if you can take the second case for positive negative values of m, positive powers of m will get, and it is multiplied with the x of z. Okay. Next one is a scaling property. Scaling in the z domain. A power n x of n is a x of z by a, or we can also write as 1 by a into x of z. The 1 by a is a scaling to the z domain. And this one is a time reversal property. Time reversal property. X of minus n is a x of z inverse. X of z inverse or x of 1 by z. Got it, my dear students? And similarly, the x of k and the x1 1 by k, that is a z power k. This will get in the time shift property itself, but here the time shift is in the multiplication factor z power m, but the k will get inside. Why it is inside? The scaling is applied the a power n in the x of n, the amplitude scaling. Here the time scaling is occurs in the z domain. But if I am taking this x of n by k here, you see the n by k to get the z power k value. So no need of this one, you can remember. Next, the differentiation property. Differentiation, that too in the z domain. Differentiation occurs in the z domain. Or multiplying n signal, n into x of n is minus z d by dz of x of z. Differentiation in z domain. And next is seventh property is a conjugate property. Conjugate property. What is a conjugate property? X star of n is x star of z star. Next, eighth property is convolution property. Convolution in time domain. Convolution x1 of n with the star of x2 of n, x1 of z and x2 of z is a product. Time is convolution. Here, frequency domain is a product. And multiplication multiplication property. Okay, x1 of n with the x2 of n, using this in the multiplication property to prove, we are using the inverse Z transformation formula. We are using the inverse Z transformation formula, my students. It is 1 by 2 pi j the integral x1 of v and x2 of z by v inverse dv. This is a dv, my students. And next is a correlation property. Correlation property in the Z transformation. R1, 2 of n is x1 of z and x2 of 1 by z. One is a normal Z transformation, other one is a time reversal Z transformation. Z inverse of x2 of 1 by z. Okay, and this also no need of this one. Sum of n is equal to minus infinity to n x of k z by z minus 1 into x of z. Forget about this one. And Parseval's theorem. And these also. We didn't cover these two properties. Linearity, shifting, scaling, time reversal, differentiation in Z domain, conjugate and correlation, convolution, multiplication property, correlation property, and the Parseval's theorem. Okay. Parseval's theorem stating that the sum of n is equal to minus infinity x1 of n and x2 star of n. Here also, to prove this Parseval's theorem, you are using the formula for the inverse Z transformation. Is 1 by 2 pi j the integral x1 of z, x2 star of z star minus 1, or x2 star of 1 by z star, z inverse dz. Correct. And initial value theorem and the final value theorem. Initial value theorem saying that limit n tends to 0 x of n is equal to limit z tends to infinite x of z. And final value theorem saying that limit z tends to infinite x of n, not the z, n tends to infinite x of n, limit z tends to 1, not it is a 0 minus. Only have to remember this. Limit z tends to 1, z minus 1 x of z. Because it is not the continuous, we are applying for the discrete. So discrete means from minus infinity to 0 means you can take from 1 to, or 0 to infinite means you can take the minus 1 to minus infinite. Got it? It's a brief description of the conclusion of all the properties here. 1, 2, 3, 4, 5, 6, 7, 8, 9. There is no here, this one. And 10, 11, 12 properties. Got it, my students? So first example, calculate the Z transform of the below. Calculate the Z transform of the below signals. So one is x of n is equal to, it given in the sequence 3, 2, 1, 0, 5. So without any arrow mark is represented in the sequence, the first value is at n is equal to 0. X of n signal is a 3. And n is equal to 1. The x of n value is a 2. And n is equal to 2. The x of n value is a 1. And so on. Okay. And now take the definition of the Z transformation. X of z is equal to sum of n is equal to minus infinite to infinite. X of n z power minus n. X of n z power minus n. That is sum of n is equal to minus infinite to minus 1. So why are they taking the minus 1, minus 1 to minus infinite to minus 1? Actually, the value is for the negative values is a 0 here, and it starts from the 0 to 4, and 5 to 5 infinite also the values is a 0. So before the values of n is equal to 0, and after n is equal to 4, the values the given in the sequence is a 0 that they are representing here. Minus infinite to minus 1, the value is a 0 here. And plus 5 to the infinite, the value is also 0. Got it, my students? So in between the values when n is equal to 0 to 4, x of n z power minus n. X of n z power minus n. So expand this value when n is equal to 0, it becomes of x of 0 into z power 0. x of 1 z power minus 1, x of 2 z power minus 2, x of 3 z power minus 3, and x of 4 z power minus 4. Okay, we already know the given sequence x of 0, 1, 2, 3, and the 4 values are 3, 2, 1, 0, 5. Substitute here. And x of 0, the 3 value, z power 0 is a 1, x of 1 is a 2, and 1 by z is a z, my dear students. Don't think it is a 2, it is a z. And when x of 2 is equal to, n is equal to 2, the value is a 1, and 1 by z square. And n is equal to 3, the x of 3 value is a 0 by z cube. X of 4, at n is equal to 4, the value is a 5, 5 by z power 4. Okay, now you can simplify. 3 plus 2 by z, 1 by z square, and this value is a 0, 5 by z power 4. Take the LCM as a z power 4, 3z power 4, 2z cube z square plus 5. Okay, now in this equation, what we got here, the z transformation, when z is equal to 0, when z is equal to 0, the total function x of z is becomes of infinite, because anything by 0 is infinite only. Got it, my dear students? So except z is equal to 0, except z is equal to 0, the entire z plane, see here, entire z plane except z is equal to 0, the given, or the not the given, the function x of z is existent. Entire the z plane except z is equal to 0. The ROC, the region of convergence, entire the z plane except z is equal to 0. For the given sequence x of n, we got the function x of z is equal to 1 by z power 4 into the function. The z we can take as a z is equal to 0. The function becomes infinite except this value, but remaining all the values of z is existent. Nothing but it is a finite value you get. Got it, my dear students? And we take this from 0 to infinite only. So always it is a unit circuit. But here the only the z is equal to 0. It is not existent, but remaining all the values is existent. Got it? The second here, another sequence is there. 3, 2, 1, and 0. Arrow mark is given here. This arrow mark represented, this value is n is equal to 0. See here. And n is equal to 0, the value is 1. N is equal to minus 1, the value is a 2. N is equal to minus 2, the value is a 3. And n is equal to 1, the value is a 0. N is equal to 2, the value is a 5. So with these values of x of n is equal to and x of n, the function, substitute in the definition of the z transformation, x of z is equal to sum of n is equal to minus infinite to infinite x of n z power minus n, and sum of n is equal to, he can take the range only. The previously we take the minus 1, infinite to minus 1, and the 5 to infinite also. That values is a 0. So in this also minus infinite to minus 3. The value is a 0 here. And 2 to, not the 2, 3 to infinite, in the range the value is a 0. Only we have the values from minus 2 to the 2. So n is from minus 2 to the 2. X of n z power minus n. Expand the value. X of minus 2. Z power minus of minus 2. It becomes of z square. X of minus 1. Z power minus of minus 1. Z power 1. And x of 0. Z power 0. X of 1. Z power minus 1. And x of 2. Z power minus 2. So the first term is x of minus 2 by substituting the value of n is equal to minus 2, the value is a 3 into z square, and here the 2 is there, 2 into z, and at the 0, the value is a 1 into 1, and at n is equal to 1, the x of n value is a 0, this term, and 5 into z power minus 2. So 3z square, 2z, 1, and this value is a 0, 5 by z square. 5 by z square. Check the LCM here to get the x of z. 1 by z square we have. Now we can substitute z is equal to 0. Z is equal to 0 here. The entire function, it becomes of infinite. X of z is equal to infinite. Got it? Or otherwise, if you take this function, x of z, now z is infinite here. If you take the z is equal to infinite, last term becomes a 0, and this value becomes of the infinite. So x of z is also infinite when z is equal to infinite. Got it, my students? But here also you can observe that when you can take the previous equation in the x of z, whenever if we can substitute the z is equal to 0 only, the last three terms becomes infinite. The first term is a 3. The 0 is infinite. 3 plus infinite, again it is infinite only. But in this equation only, the last term becomes is a infinite. 5 by the infinite. 5 by the infinite becomes a 0, and the remaining the two terms becomes infinite. So the entire the z plane except 0 and the infinite. Previous condition, entire the x plane except the z is equal to 0. But for these given equations, the ROC, the region of convergence, is entire the z plane except z is equal to 0 and z is equal to infinite. And the remaining all the values, the function is existent. It is not getting the infinite, it is getting the finite value only. Got it, my student? That is the ROC. How we can find the ROC means the function x of z what we have. Can substitute the z values. It is not equal to the infinite. Then only it can exist. If it is infinite, it is not in the region of the convergence. It is unbounded. It is not in the bounded conditions. Got it? Next example. Third example, x of n is equal to 0.5 whole power n mu of n. 0.5 whole power n mu of n. We already know a power n mu of n. The function is 1 by 1 minus a z inverse. 1 by 1 minus a z inverse. What is the a here? 0.5. 0.5 is nothing but 1 by. Okay. So according to the function a power n mu of n, the z transformation is a standard z transformation. 1 by 1 minus a z inverse. With ROC, the region of convergence z is greater than a. Got it, my student? This is given only this function. Or otherwise, directly don't use this one when they given in the 3 marks or the 4 marks question. It's a 1 bit question means then only you can write directly the a power n mu of n is a 1 by 1 minus a z inverse. Instead of a is a 0.5, 1 by 1 minus 0.5 z inverse directly can write it. But if they ask in the 3 marks and the 4 marks means you have to show the procedure. You have to substitute in the given x of n in the definition of the z transformation. Then you can simplify and finally you have to show the answer. Got it, my students? Now for that I am taking here the x of z is equal to sum of n is equal to minus infinite to infinite x of n z power minus n. Mu of n is substitute the a power n mu of n. Mu of n is only the right side function. So I split the two parts as minus infinite to minus 1 and 0 to infinite. Minus infinite to minus 1, the values becomes a 0 here. You see here, the 0. and 0 to infinite 0.5 whole power n z power minus n. The mu of n value is a 1. So 0 to infinite 0.5 is a plus power and z power minus n. So both you can keep that as 0.5, nothing but is a 1 by 2. Inside you can keep that is a z power minus 1 whole power n, as sum of n is equal to 0 to infinite. This is the equation actually. We know the formula. Sum of n is equal to n1 to n2 a power n is a power n1 minus a power n2 plus 1 by 1 minus a, and a is greater than the 1. In that we can substitute. In that we can substitute the value is, or you can expand. Here the expansion is there. A plus AR plus AR cube and AR power 4 and A power 5 and so on. That is 1 by 1 minus R. Got it, my dear students? Now I am using this a function. When n is equal to n1 to n2, a power n is equal to a power n1 minus a power n2 plus 1 by 1 minus a, and you have to have the conditions n2 is greater than n1 and a is less than the 1. A is less than the 1, my dear students. Using this formula in this equation, instead of a is 1 by 2 z inverse, n1 is a 0, n2 is a infinite. That is equal to a 1 by 2 z inverse whole power 0 minus 1 by 2 z inverse whole power infinite plus 1, because n2 is infinite here, whole divided by 1 minus 1 by 2 z inverse a. And what is the a here? 1 by 2 z inverse is less than the 1. As a condition you have to satisfy. So anything power 0 is a 1, anything power infinite is a 0, whole divided by 1 minus 1 by 2 z inverse. 1 by 2 z inverse. Nothing but the value is 1 by 1 minus 0.5 z inverse. Okay. So we got this function a power n mu of n is 1 by 1 minus a z inverse. Instead of a here 0.5. Directly we got x of z is equal to. But what is ROC? What is ROC? 1 by 2 z inverse is less than the 1. So 1 by 2, nothing but is a 0.5 by z is less than 1. Okay. 0.5 is less than the z. And z is greater than a, greater than 0.5. See, this ROC we have. Similarly, z is greater than a. What is the a? 0.5. Okay, z is greater than a, nothing but is a 0.5. The ROC is outside the circle of with radius 0.5. With the radius of 0.5, this is totally outside the circle 0.5, the region of convergence. For all the values of greater than the 0.5 of the circle, the x of z is exists. Nothing but is a bounded. Remaining all values is not bounded function. Okay. You see here the z is greater than 1 by 2. And x of z is 1 by 1 minus 1 by 2 z, or 1 by 2 z inverse.